Hey, there we go. All right, we're back up. All right, let's copy link. Morning, guys. After some. Today's lesson. All right. Post that there. Let's do, and these guys are. Okay. That's view material. Concept in a variety of ways. Oops. Um, okay, okay, alright. Check emails. Let's go to homeroom. Where's homeroom? So I should have got the code for that. Emily. Alright. Hey, I'm assuming K-Chap. That'll be either Kayla Sky or Kiara. Yes, I absolutely can. Definitely, I can, and I absolutely will. So, trying to put some year sevens in their place. All right, let's do year 10? 10N. That's what we're looking for. Non-linear relationships. What? Have we not done that? All right, that's right, because we've done this. Okay. Alrighty. Kiara. Awesome. Alright, cool. Hang tight, as we may have some technicals. There does get a bit glitchy along the way. But yes, absolutely. We will definitely do parabola stuff. Because I'm assuming you, like many others, were like super stuck and like are super confused. Oops, and let's change that because we're not doing year 7 either. Let's change that to that. That's what we want. Cool. Very. Okay. Yeah, because it's kind of like we were doing data and stuff like that, and then boom, all of a sudden we're getting smashed with this, right? Okay. So let's talk about what we kind of were doing, the skills that we need to know leading into this, righto? I will start. I might actually start a brand new document. Let's change paper. That and that. Okay. So let's pull you over here. Let's talk about the things that we kind of need to know, okay? Or the things that we're going to be using along the way here, all right? The first thing that we need to know is we need to know our thing about equations, okay? Equations. All right, in particular, the thing that we were looking at the start of the year, term 1, we looked at linear equations, right? And that was the idea that we took an equation, something like y is equal to, let's say, 2x plus 1, right? We took something like this, and we then went ahead and we plotted it on a Cartesian plane, like so. So we'd go ahead, we'd draw up our Cartesian plane, and we would kind of say, all right, well, if x is equal to 1, then y is going to be equal to 3. So that would form the basis of my coordinates, right? We would then go, all right, x is, let's say, 1 here, y is 3 there. That's that. When x is 2, then y was going to equal 5. So x is 2, y is 5 there. And we worked back the other way, right? When x was 0, y would equal 1. And you can start to see here on my page that already we formed ourselves a nice little line, okay? Hence the term linear equations, right? We're creating lines based upon equations. Thing about parabolas is that they work in the same way as that we're doing here, except we have one tiny difference. The difference being that instead of having just straight up variables like so, our variables are going to often be squared, like so, okay? This changes the way that we look at these equations, okay? I'll explain. I'll understand why we call it parabolas in a minute. So let's just go ahead and explore what this is here, all right? And we're going to do that by putting it in a table of values. So I'll go ahead and I'll quickly just draw up a table of values like so. So there is x, there is y, and we'll do just a handful of these. I'm going to do, actually I might add one more. Like so. So I'm going to start, say, when x is -2, when x is 1, when 0, 1, 2, like that, okay? So what we'll do is we're using this formula here, or this equation here, what we're going to do is we're going to substitute -2 into x, right? So I'll pull up my calculator, so you can see as well too that I'm not just tricking. All right, let's go over here. Why? I don't care for history. There we go. Okay, there's my calculator here. So I'm going to go ahead and we're going to say, all right, well, -2, so negative, oh, that's right, this calculator is really weird. So you put 2 negative squared, there's my little squared button like so. That guy equals 4. Cool, let's do that. All right, because of course, -2 times -2 is 4. -1 times -1 is 1. 0 times 0, well, is 0. And 1 times 1 is, of course, 1. And 2 times 2 is, of course, 4. Hopefully you can kind of begin to see kind of what's happening here, right? You can see that even though I've got a 2 here, it's 4. And I've got a -2 here, it's also 4, right? This is what makes parabolas really strange. Whereas over here, if I put in, let's say for example, if I put in, let me get a different color here. So I had 1 is equal to 3 in this formula here. You can't see that. 1 is equal to 3 when I did that there, like so, right? If I said that we did -1, well, -1 in this formula is going to be, well, 2 times -1 plus 1 is 1, right? Where the opposite is true here, right? When we have 1 here, y is 1. When we have -1 here, y is 1. And we just kind of proved it, like mathematically, right? We went ahead and proved it. Undo. Let's make you smaller. We went ahead and proved it. So what we actually do now is we go ahead and we pop this guy on a Cartesian plane. And I'm sure, actually I might use this Cartesian plane that's up here. Let me just move this. I'll use this same one just to compare, like so. All right, what we'll do here is we'll do this first coordinate. I'll do it in blue. When I've got -2 for x, which is there, y is equal to 4. So that's there, like that. When I've got -1, y is equal to 1, which is there, right? When I have y is x is 0, y is also going to be 0. And then the inverse, or the opposite, is true, like so. So you can see here, let me try and draw a line here, that we create this weird, funky curve, like that. This guy here is called a parabola. All right, this guy here is called a parabola. And I can see you going, well, why the hell do they call this weird, funky curve a parabola? All right. The thing is, like, a lot of these things in maths actually are given like actual names. And like you can go ahead and you can actually, like, if you go into like just Google and you type in parabola etymology, see that? Parabola etymology, it can actually go ahead and it breaks down exactly where it kind of came from and how it came to be, right? You can see, I don't know if you can see that. I'll try and zoom in. Control zoom. Yeah. You can kind of see here, right? It comes from parabola, meaning like parallel, like para from parallel, meaning side by side, meaning like to be mirrored, placing side by side. Parallel throw, like so. Parabola. If you think about it though, like, we understand the whole parallel bit, right? Because if we draw a line down the middle here, oh, actually you can't see that. Let me put that back up. If we draw like, let's get a purple. If I draw a line down the middle here, like so, you can see that it's parallel on either side, right? But where the heck do they get the name bowler? Well, think of it like this, right? Think of it in terms of, let's say, we'll draw a little picture. Let's say that you're standing on flat ground, like so. Okay, that's you standing on flat ground. There we are here. We're kind of standing just about there, like so. Now, let's say this is one of those weird extreme events where there's no wind resistance, there's no nothing. What you've got in your hand is you've got yourself a little ball, righto? You've got yourself a little ball. You get that ball and you throw that ball as hard as you can. Now, assuming that there's the only two forces acting upon it, only two forces are your throw and gravity, right? There's no wind resistance or anything like that. What would happen is your throw would go up and it would go down like so. It would create, well, the path from which that ball would be thrown would create what we call a parabola, like so. Something that you can actually measure like that, where this value here on this side is the same as this value here on this side. Obviously mine's not to scale, but you get the idea, right? So henceforth we get the term parabola like that. All right. Does that make sense? Does that make sense? Hopefully. There's about a 10-second delay here, so I'll check the Google Classrooms while we wait. Yeah, cool, awesome. Do you understand how we kind of, do you understand how we were able to plot this equation? I'll write it again. You understand how we were able to plot this equation into the table of values? We want to get out of that and into that. Cool. Hopefully that does. I'll just assume that it does. Because the notion of kind of plotting it, the notion of plotting it onto a Cartesian plane shouldn't be too unfamiliar. We've kind of been doing it since kind of year 8 and into year 9. I think so. When I looked at the worksheet yesterday, after watching the videos, I was lost. Yeah, okay, I can understand. All right. So now what we can do is we'll just go through a few of the questions for you, right, and kind of go from there. Before I go and just kind of dive into each of these questions and whatnot, was there any questions in particular that you were kind of stuck on, or you were like looked at and going, what the hell are they actually asking me? Oh, you didn't try. Okay. All right, you're too overwhelmed. Okay. Well, let's go through a few of these questions. Let's try and like take the fear out of you here. Righto. Let's take the fear out of you here. Okay. So let's go ahead. Oh, hang on a minute. Give me a tick. Oh, yeah, cool. That's fine. Okay. Let's have a look. Okay. All right. Now, let's go through. I will put this up on the screen and we'll go from here. All right. Here it is here. Here's that first exercise. All right. Copy and complete this table and grid to plot the graph of y is equal to x squared. Well, you can see this is pretty much exactly what we did just here, right? So, again, negative 2 squared was 4. That was 1, that was 0, that was 1, that was 4. And you can see, given that the pattern kind of mirrors here, it parallels each other, that this one over here is going to be 9 as well too. So all it simply wants us to do is just exactly what I did before, is go ahead and plot these values, okay, based upon this formula here, this function. 0, 0 is there, that goes there, that goes there. This one goes here, and of course it parallels onto this side here, like so. This one over here then parallels up to here, and that one parallels up to there, like so. Okay, parabolas. And then of course you can draw draw your curve. Hopefully yours would be better than mine, like so. So really, this is kind of what this chapter is about, right? Like, it's just about exposing yourself to the nature of parabolas, okay, in particular like this one here, and getting comfortable with the notion of their shape and their form on this graph. What the heck is this question asking? Write the missing features for this graph. The parabola has a, what's the heckaroonie? The parabola has the coordinates of the turning point are, the x-intercept is, oh, okay. Righto. They're kind of focusing on the language here, right? So in our summary here, all right, this is where kind of our key information are. So if you get to a question like this, which I'm stuck on, I'm going, what the heck are they asking me? You can use these examples here, and you most definitely, certainly should be kind of using this. So a parabola is the graph of a quadratic relationship. So a quadratic relationship is just anything with like a power like that, like we've looked at. The basic parabola has the equation of y equals x squared. Yeah, that's what we just looked at. The vertex, or the turning point, is 0, 0. So we can see that there. It is a minimum turning point. All right. So essentially, what that kind of means is like it means like that's where it kind of essentially just says that's where it's turning. The axis of symmetry is x is equal to 0. Okay, we can see that because, you know, it parallels like so, because this side here is exactly the same as this side over here, like so. The y-intercept, so remember the y-intercept is where the line runs through the y-axis, and the x-intercept is where the line runs through the x-axis, okay? So, using that information, let's break this down. This one here has a turning point? No. The coordinates of the turning point, let's just go to the next one. The coordinates of the turning point are, well, you can see, right, it turns up the top. I'll get a different color than blue. All right, you can see that it turns, if we started to throw it, right, it throws up along here, and then it turns at this coordinate at the top here, like so. So you can kind of go, all right, well, the turning point here is -2 and 4, like so. The y-intercept, so that's where the line runs through the y-axis. So of course, here is our y-axis, just here, and you can see that it's actually labeled it for us, right? It goes through 2. The x-intercepts, now there's 2 x-intercepts because our x is there. So our 2 x-intercepts are -5 and 1, pardon me. And the axis of symmetry is at this point here, when x is equal to -2. X is equal to -2. Like so. All right. Hopefully that makes sense. Determine these key features on the following graph. Okay, so you can see here, well, let's start with turning point, right? Turning point is really, really easy. Turning point is here. Here's our turning, I'll just do TP. There's our turning point there. There's our TP there. And our TP is here for that. That's our turning points for those guys there. Our axis of symmetry for each of these. Remember, our axis of symmetry is where it intersects on the x-axis. So our symmetry here, this will be x is equal to 2. Can count, yes. X is equal to 2. Axis of symmetry here is again on our x thing, so it's x is equal to 2, like so. And then axis of symmetry here, again, wow, look at that, it's labeled it for us. X is also equal to 2. That's where our axis, okay? Because remember, we're talking about our axes, and that's where you know, our x-axis and our y-axis. So at the point of symmetry, it's on our x-axis here, like so. All right, x-intercepts. Well, let's do this. There's one x-intercept over here, like that. Okay. There's the other x-intercept there. So what's that? -1 and 5. x-intercept here? Well, there's only really one intercept, and that's this point here. That's this point here on this guy here. That one is 2. Our x-intercept here, this actually doesn't have an x-intercept. So we can say that this purely simply like has none. There is no x-intercept. It doesn't go through the x-axis at all. And then, of course, our y-axis, right? Where does it, our y-intercept. Where does our line cut through our y? So if we have a look at our line here, it goes down and around and up. And you can see it cuts through at -3. There, like so. That's our y-intercept. Similarly over here, you can see it cuts through our y-intercept here at -1. And this guy here, this looks like it's going up in intervals of 2. So my y-intercept here is going to be 5. Like so. Okay. Making sense so far? Making sense so far? Let me check the chats. See if anyone's written anything. Oh, I doubt it. Everyone's taking a break. Nothing there. Nothing in 10A and E. Cool. Awesome. Yay, I'm glad. All right. So I'll keep going because we've still got plenty of time. So if you want to, you can kind of go ahead and yourself, or we can just sit here and do this together. That's cool. We've literally just done it for A, B, and C. I'm not going to go ahead and do it for D, E, and F. I think you get the gist. I'll let you decide how to do that and how to calculate that. Copy and complete the table below for the following graphs. Copy and complete the table below for the following graphs. What the heck? Okay, cool. So there's our table. So this minimum or maximum value is really freaking me, is doing my head in. I'm not sure exactly how to solve this, right? So again, here's another resource that we can use, right? We want to go into the Google Classroom. We are going to go up to nonlinear relationships. Have I not given the answers out? Oof. I haven't given the answers out. Have I not given the answers out? I don't think I have. All right. Let's put the answers up right now for you. That will help, right? That would be a super duper help. So while I'm putting the answers up, if I was you, I'd to just take the time to do questions D, E, and... Oh, there it is there. Take the time to do questions D, E, and F. Just give me a tick while I put the answers up on the Google Classroom. All right, let me just do that. So we want 9. So we will put, we want stage 5. No, answers. Cambridge 5.2. What page are we on? Is that right? No, 10. Cambridge, that's what we're on. All right. If you have any questions, just let me know. Give me a tick while I put this up, because the world needs answers. It's a good learning tool. Okay. We are on pages 76 through to 76 through to, it's a big chapter. Let me just, what I'll do is I'll put it, each chapter, I'll fix this up today. 1, 2, 3, okay. 76 to 78. Okay. Alright, let me just stop mirroring for a second. And we want to export to Google Drive. We want to change that. 10N, export to 10N. Back. Okay. Edit. We want to add Google Drive file. Insert that. All right, cool. Let's save that. All right, cool. There we go. It should be updated there. All right, cool. So the answers are there. So let's mirror you back. Do that. We're live. Okay, let's fix you up. Okay. So, question. Okie doke. So, here we go. Let's copy and complete this table. So I'm going to start with turning point for the following graphs. Okay, so let's have a look at A. Rather than kind of do, oh cool, it's actually given us the formulas for A, how they've calculated it. All right, so for this formula in A, so we're looking at the blue formula in A, right? And we're comparing that against the red formula, like so. And so although this is unrelated, can I take study notes for the test instead? Look, you can, Vasilius, that's fine, mate. You can absolutely do that. But, you know, we also got to prepare for the fact that perhaps, we know, may not come out of this, right? So, you know, do what you need to do that'll get you by this week, and then we can kind of go from there. All right, so let's have a look-see here. Is our red one, is our red guy here reflected on the x-axis? Well, remember what a reflection is, right? We're doing one more week of lockdown, did they say? I haven't seen the news, mate, so I got no idea. One more week, eh? There you go, another week of this. So yeah, look, you guys do what you're gonna do, but ultimately, you know, you can still take your study notes, you can do what you're gonna do, but we're still gonna move on, I guess. Reflection, remember, right? So reflection is this. So if I have a line here, that the reflection of that would be this here, like so. Okay, obviously much better reflection, but you get the idea. You get the gist, right? Like it's gonna be like something like that, right? So if we have a look at this one here, are they reflected? Well, no, they're not reflected. The turning points is of course at coordinate 0, 0, like so. The y value, what's the y value when x is equal to 1? So if we have a look at our red, when x is equal to 1, my y value is, wait, is that right? My goodness. Let's have a look at the answers. Let's see what the answers are giving us, because I'm not sure if I'm answering these correctly. 0, 0. So the y value when x is equal to 1. Are we looking at... right, okay. Far out, man. They haven't worded this question properly at all. So it's quite clear what they're trying to do. So using this formula, so in this formula, when y is equal to 1, when x is equal to 1, y is going to be equal to 3, because, 1 squared is 1 times 3 is 3. Yeah, so that's that. Is wider or narrow then? So, of course, it is narrower. It is narrow. So this formula is narrower. I don't know what they're asking about minimum or maximum. That's actually frustrating me, and I'll find out the answers to that and how they get that. This guy here, let's have a look. Is this reflected? No, they are not reflected. No, they're not reflected. What's the turning point? The turning point is 0, 0. When x is equal to 1, y is going to be equal to 1/2. Can you see that? Hopefully you can see that, right? Because remember, 1 squared is just 1, and then 1 times 1/2 is 1/2. So that's that there. Is it wider or narrower? It is wider. It is wider than that. So you can see that, right? That's an interesting thing to note, right? You can see that. It's wider. When we're dealing in fractions, maybe it goes wider, right? Let's have a look-see here. This one here, is it reflected? No. The turning point again is 0, 0. When y value, when x is equal to 1, well, of course, again, same deal here. I substitute 1 into x, like so. My answer is going to be 2. And is it wider or narrower? It is narrower, as you can see. All right, it's narrower. Narrower. Like that. Hopefully you guys are getting the gist of that, right? Hopefully you're getting the gist. And remember too, you can use the answers, which are now put on the thing, yeah. Min or max. I need to figure out what that actually means. Okay. The answers I've just put up on the thing, so that they are there. It says Cambridge, stuff like that. What's the wider and narrow thing? Oh, so it's saying that, right, is this formula here wider or narrower than this formula here? Oh, actually, you can't see that. Far out. That doesn't help. Let me do that again. Is this formula here wider or narrower than this formula here? So you can see they've kind of used y equals x squared as the basis for each of these. So you can see in this problem here, right, when I have a coefficient greater than here, that it's going to be narrower, like that. When I have a coefficient here, which is smaller than 1 of this, it's going to be wider, like so. Again, same deal here. Bigger coefficient than the one that exists there, and it's narrower. This one here is, although it's kind of like a -4, you can see, like we understood beforehand, that it doesn't matter whether we're doing positives or negatives, given that it's the integer value of 4 is larger than 1, okay, it's actually narrower. Same deal here. We have got a fraction, so it's going to be wider than that. And same deal here. We've got a whole number here, or a whole integer, and that is going to be narrower than this guy up the top here, like so. They're just talking about how when you manipulate or you put whatever number is in front of your coefficient, it changes kind of essentially how narrow or wide your parabola is. So it's kind of akin to like saying, if we go back to this and my explanation of the throw, right? Let's say for example that this throw represented y is equal to x squared. Let's say I have another throw like so, and I'll put another one. Let's say my throw is y y is equal to 2x squared, like so, my throw, like as an image, would look something like this. Not too dissimilar, but slightly narrower, like that. So let me now take that. Let me just take that. Oh, cool. I'm glad you guys are enjoying it. So let's take this, and you can see, right, that it's going to be, well, I haven't done it to scale, but by putting it over the top there, it's made it slightly narrower. Okay, essentially, so that's what it's saying. So actually, let's undo that. And I'm going to change the color. No, undo that. I'm going to change the color of this to highlight that. Style. Let's change this to, like, say, green. No, you can't see that. Red, you can see. So there we go there. Like that. So that's the difference, right? So my black one here, that would be equivalent to saying y is equal to x squared. And my red one here, that would be equivalent to saying y is equal to like 2x squared or something like that. Like that's the difference. Because, oops, we're glitching out. Because this has a coefficient here greater than 1, what this is, it's going to be smaller or narrower. Hopefully that clears some of that stuff up, like so. But yeah, I can understand why you would be freaked out by these questions, because they're hard to deconstruct. Even I'm struggling to deconstruct them. Copy and complete the table for the following graphs. So again, you can see in each of these questions down here that their baseline has been this y equals x squared, and so they're just comparing other formulas to y equals x squared, like so. So here, the turning point for this formula here, turning point for that formula there, I'll keep it in red. Let's have a look at A. So the turning point for A is at this point here, you can see there. So that is, what is that? That is -3, 0, right? It's -3 across the x-axis and 0 up the y-axis, like so. The axis of symmetry, okay, remember that's where the point where one side is the same as the other side, just reflected, right? So the axis of symmetry is x is equal to -3, because that's where the symmetry point starts and ends, right? It's the same as kind of the turning point. The y-intercept, where x is equal to 0, and again, is -3. No, wait, no, that's wrong. Sorry, it's wrong. The y-intercept looks like, holy dooly, it's like up here, right? So the y-intercept is like right there, right on the end, because that's where it hits in the line. So the y-intercept when x is equal to 0 is 9. And of course the x-intercept, well, where our line hits, the same deal as we've been doing before, this guy down here. That guy is, what did we say, -3. That's where it hits at the x-intercept, like that. Okay, so that one's a little bit easier to deconstruct. Same deal down here. Again, turning point. It's asking us for each of these values. So again, using this formula as your baseline, identify what the turning point is, y-intercept, and what is the y value when x is equal to 1. Well, here, let's go through this, right? The turning point for this formula here, which is this one here, the turning point is right in here. Hopefully you can see that. That is, what are we? We're 0 on our x-axis, and we're 3 on our y-axis. Our y-intercept, of course, well, it's that same point there, is 3. And what is the y value when x is equal to 1? Well, let's substitute that with a 1. 1 squared is 1. 1 plus 3 is 4, like so. That's that there. Hopefully that kind of helps and can kind of give you a bit of a head start. Write down the equation of the axis of symmetry for these rules. Write down the equation of the axis of symmetry for these rules. Far out, man. Yeah, I can see why your eyes would roll in the back of your head, right? So again, I don't know what that question's exactly asking me. So write down the axis of symmetry for the graphs for these rules. Oh, okay. Remember the axis of symmetry as the point, I remember, is the axis of symmetry is the point at which our parabola like starts to curve back again. It's like, so it's this point here, right? So if we remember and we think about and we recognize the patterns up until this point, our axis of symmetry was when x is like equal to 0. Is that right? Yeah, it's when x was equal to 0. It happens. So like in this one here, right? So my axis of symmetry would be when x is equal to 0, right? So if x is equal to 0 here, well, then it would be 0. Over here, is that right? Yeah. This one here, when x is equal to 0 here, like so, my axis of symmetry is 7? No, that can't be right. Again, let's check the answers. What question is this? 7AB. No, it's all right. See, I was right. Look at that. X is 0, x is 0. Let's have a look where x is 2, right? So let's have a look at 7f. 7f. Aha. X is 0, x is 0. It's 4. So let's plot this guy. I'm just going to quickly plot this guy. The axis of symmetry. I'm going to plot this guy. So this guy here is when x is 0, y is negative 4? No, it's positive 4. It's positive 4. Let's do this. When that is 1, that is 5. When that is negative 1, that is 5. When that is 2, that is 8. When that is 2, that is 8. What they say? X is equal to 2. How do they get that? I don't know how they get that. Leave that with me. My brain's fried. My brain's fried. I don't know about you guys. My brain's fried. What you can do as well too, like you can get stuck on that, which is what I'm going to do, is I'm going to jump on this, and I'm going to go, let's zoom out again. If I go find the axis of symmetry for parabola. So you can have a look, right? Like finding the axis of symmetry for a parabola. Boom, there's like tons of stuff here. I'll do Math is Fun because I like that website. Math is Fun. Parabola, definition, axis of symmetry. Yeah, well, we know that for a parabola. Focus and axis of symmetry. So again too, like you're going to get a bit bombarded. So here's the hot tip. Use the find button, like so. So if we go axis of symmetry. Symmetry. Here we go. Yeah, we go. So yeah, that's the axis of symmetry there. So where it does it. Still doesn't help us find it, right? Write down the equation of the axis of symmetry. Let's do it. Write down the equation. Axis of symmetry. Oof, that's brutal. So for the axis of symmetry shown, the x-coordinate and the vertex is the parabola. So x is okay, cool. Yeah, right. The x is 2. That makes sense. Find the axis of symmetry for y. Plus using the formula. Quadratic function. Yeah, blah blah blah. Hence, blah blah blah. So substitute. Still doesn't help me, right? Anyway, I'll figure this out, and we'll have a look at this next lesson, I reckon. All right, I think I'm done. I'll have a look at this a little bit later, figure out exactly how to calculate this, and we'll do this together, right? That's how we roll. Cool. All right, does anyone have any more questions? No? Yes? No worries. Thanks for hanging out, Kiara. Hopefully that helps, right? All right. Not really. Oh, cool. I'm glad it helped. Right. Yeah, we'll kind of work out what this section is here. Give me a tick. But the main thing is, right, that we kind of understood at least the basics of this language at the top here, right? We understood this. We went through this. We understood the formulas at the very least. We understand that we're working with graphs and stuff. But I reckon next lesson we will tackle these guys here. We'll work through some of the more hard stuff here. All right, we'll nail this chapter. You're welcome, Zach. Hey, Zach's here. Good on you, Lockie. All right, mate. You guys take it easy. Enjoy whatever you got next. I don't know what you got next. Oh, dear me. Go have some lunch or something first before you nail down the last one. No more questions. Yeah, no more questions. Good. I'm glad. All right. We'll do it again tomorrow, right? Bye.
For this problem also,
For anyone that's still here, this is how we solve problems, right?
asking us to do is write the equation of the axis of symmetry. This given to us is an equation or a function of a parabola, quadratic function. It's also known as that as well. So the formula is something that we have to memorize. It's not always given to us. So the formula is x equals negative b over 2a.
Ugh,
We
gross.
find the variables b and a by looking at our original equation. A is always a number in front of x squared, so in this case that's 4. B is always a number in front of x, that's going to be 7. And C is always a number without a variable. In this case that's negative 9.
Okay, so let's try and work this out. Okay, so I'm going to pause there. Let's work this out. Write an equation for the axis of symmetry. Answers. Let's have a look at this. Copy and complete. This one is tricky. Write down the equation for the axis of symmetry for this.